Hello everyone. Today we will solve a mathematical example of exponential distribution. Assume that the time between arrivals of customers in a bank exponentially distributed with mean 4 minutes, and we have to find the probability that the time between arrivals is greater than 5 minutes. So we are given some important information. First one is the distribution that it follows, and it is exponential distribution. So we are going to use exponential model to model this situation, and we have also given the mean of 4 minutes. So the model that we are going to use here is probability of x is equal to small x is equal to lambda e to the power minus lambda x, where x is time between arrivals, and here capital X denotes the random variable and small x denotes the observations, and here we have a lambda, which is a rate parameter. See, the rate parameter value is not provided by the problem, so we have to find it using this mean. So the rate parameter will be, it is exactly the inverse of the mean, so it will be 1 by 4. And next, now we are ready to find our desired solution for this problem. Find a probability. So they are asking me to find the probability. So we are going to find a probability of what? They are asking me to find the probability that time between arrivals is greater than 5 minutes. So we denote the time between arrivals is x, and which is greater than 5 minutes. So greater than 5 minutes, we can write it like this as well: 1 minus probability of x less than or equal to 5 minutes. So whenever we're going to extract this probability less than or equal to 5 minutes, we have to use the CDF formula, or to perform like this: 1 minus, we are going to use the model right now. Okay, lambda e to the power minus lambda x. We cannot directly write this one because they're giving us the bound, not the exact value like this: x is equal to a small x. So they are giving me less than or equal to 5, so there will be 1 to an infinity number of number between 1 to 5, or 0 to 5, sorry. So we are using this integration to model this one, 0 to 5, and we will differentiate with dx, and we are going to have 1 minus lambda will be out of there, and it will be lambda integration 0 to 5 e to the power minus lambda x dx. Next, what we can write: 1 minus lambda, if we integrate it, now we will have e to the power minus lambda x divided by minus lambda, and sorry, and we have 1 minus this lambda, this will cancel, so there will be minus e to the power minus lambda x now we have 1 minus, so I did mistake, this is the limits, there will be 0 to 5, and I will put the limits into them, and I will get minus e to the power minus what was our lambda's value? 1 by 4, so it will be 4 and 5, and it will be minus, and it will be plus e to the power 0, minus 0, sorry, minus not 0. And now I have 1 minus e to the power minus 5 by 4 plus 1. Next I have 1, sorry, e to the power, sorry, 1 minus 1 plus e to the power 5 by 4 minus 1. This one will be cancelled, and I will left with e to the power minus 5 divided by 4. And now, using calculator, I can find out this value. E to the power, sorry, e to the power 5 divided by 4. So it is 0.2865. So this is our answer for the problem. And there is a direct solution for the problem, and it is the way of CDF. We know that for exponential distribution, the CDF denoted by f of x is 1 minus e to the power minus lambda x. And our problem is to find the probability of x greater than 5, which I can write it like this: 1 minus probability of x less than or equal to 5, right? And if you look at this is exactly the CDF is. So I can directly put the CDF formula here: 1 minus e to the power minus lambda x, and this one will be cancelled, and this will be plus, so e to the power minus lambda x. What was our lambda? Was e to the power minus 1 by 4. So what was our x was? Yes, our x was this 5 from the definition of the CDF, because this CDF I can write it like this one, or else also probability of x less than or equal to x. Okay, so what was our x will be here? Yes, x will be the 5. So this is the answer, 0.2865. And this is the simple and direct solution for that.